So it wasn't really a SaaS in terms of engineering, and around 10 years back there wasn't too much of SaaS. So we called ourselves SaaS, and we got lucky and we got funded by IDG Ventures because we had a lot of cool stuff and then a business-friendly term called SaaS, which was interesting. And eventually we grew the business to a certain level. The business especially grew in US, not so much in India. I mean, we had around 300 customers in India, enterprise, but we were not making that much of money. So I wanted to tell this because some of the things will tie it up later on in terms of the adoption part. So anyway, eventually we got acquired by a US company called Cigital, and right now I was just telling that I have less things to do.
All right.
So over to
All
you.
right, thanks. So Venkat, before you start, we have only 25 minutes, so I'm penalized 10 minutes, so let's have your quick intro.
Okay, that makes it a lot easier for me, right? So my name is Venkat Krishnapur. I'm the head of R&D operations for Intel Security. We used to be called McAfee before Intel acquired us in 2010.
Okay, great. Anand, Prahlad, I'm president and CEO of a startup called ParaBlu, a cloud security startup. Prior to ParaBlu, I was actually with McAfee, and I spent several years there. And prior to McAfee, I was with a company called Commvault, where I ran engineering for them worldwide, storage, data management, etc. So my background is enterprise software. You know, I've done that all my life. Storage, security, etc. So that's a little bit about me.
I'm Supriyo. I'm a vice president in Wipro. I look after our software product engineering business, and part of it is also security. So we are also, my division also take care of the security engineering part.
All right, so let's start with the discussion. So as I said earlier, the part one of the discussion is going to be understand the evolution of the threat itself. So let me start with you, Venkat. So around 20 years back, when I touched a computer, it was all about a simple virus. It sounds simple today, but it was terrifying those days. So how do you think the threat itself has evolved over the 2 decades?
Yeah, that's a great question, Ashwin. So, to answer your question, I think I'll have to kind of address it in terms of decades, right, starting from the 1980s. The first well-known discovered virus, I mean, there are many claimants to it in the past as well, but, officially recognized, it was in 1981, the elk coroner, which was strangely on the Apple platform. Right, and then so the first 10 years was really the phase where the viruses were getting created. The first known MS-DOS attack was in 1986. The Pakistani brain. These were 2 doctors who created this virus because somebody was stealing some of the information. Sorry about that. Modern technology always invades, right? And then, so that was the first stage of evolution. So when you look at it, it was mostly viruses, that would be passed around from floppy drives and so on and so forth, right? The 1990s was around the discovery of the polymorphic and the macroviruses. The 2 big names that come into mind are Melissa and Michelangelo, right? I mean, these are the 2 big ones that happened during that time. So when you look at the first 20 years from 80 to 2000, these were mostly viruses that were created by people for the sake of fun, and typically in garages, youngsters looking for fame. They're not like highly. They were not like mass mailing, mass worms kind of a thing. The worms started kind of getting into the picture in the 1995. And then when you look at 2000, that's really when, the vulnerabilities in the Microsoft system were beginning to get exploited. You think about Outlook, you think about the MS SQL Server, you look at a whole range of Microsoft products getting exploited. And that's really when, the first 2000, the I Love You worm, and then you had Sasser, you had, the MySQL Slammer, which brought the entire world down to its knees in 15 minutes flat. This was in 2003, right? And this was the beginning when the networking, the social networking revolution began. The number of systems that began to talk to each other, connect to each other, was growing up in an exponential manner. 2008 kind of represented that when we had the coup face attack. So Facebook, when you reverse it, is coup face, just so you know. That was in 2008. So typically, it was the era of the super worms, as so to speak. And then, from an attack perspective, they happened very fast. They were also able, they were very visible. You could come up with an antivirus kind of a solution pretty fast for these. And like I said, it was mostly for gain and mostly for fame, and not really for making money and things. Switch to 2010. That's really when things begin to change, right? There was government-sponsored espionage. You look at Stuxnet, right? For those of you who don't know what Stuxnet is, this is the malware that essentially destroyed Iran's nuclear capabilities during that phase. And you had things like Project Aurora and essentially government-sponsored cyber warfare, cyber terrorism, and in terms of the kind of malware that was getting created, it was more stealth, covert. They would move quickly from one. Detection was almost impossible. They would lie low for a long time. So they came under this category of, APTs, or the advanced persistent threats. And then, as you move into 2010 forward, it's about ransomware. And then you have all of these coming into the picture where, it's essentially how you're able to encrypt malware and then take over machines and then demand money. So it was all about, it was about software, malware being written by professionals, sponsored by the government, more for cyber terrorism, more for making money, and so on and so forth, right? So, and when you look at where we are today, I mean, the data is staggering. We're kind of, the number of hits that we get on our GTI system is almost close to 44 to 45 billion. And then you're looking at about, close to, 500 malwares being written per minute. And then you're looking at a database of close to 500 million. And then you think about the kind of attacks that you have, it's data loss, data prevention, privacy leaks. There's a whole range of things, that are happening today. And the most important thing is, in terms of detection, you need to have a significant amount of firepower in order to be able to detect and then, B, remediate, right? So that's really the state in which we are today.
Mm-hmm. So as you mentioned about government-sponsored terrorism, in fact, I just recall one instance. So I was in Beijing last year. One of my customers actually pointed at a building near the Forbidden City, and he said, this is where it all starts from China-sponsored cyber attacks. It's very scary. So, all right, so coming to you, Bikash, so one important thing is over the last 15, 20 years, there is a virus comes, you try to contain it, and then there is one more new virus comes, and similarly the attacks, they get far more robust and, dangerous. So, in summary, security has never been foolproof, right? What went wrong?
Actually, in a way, nothing went wrong.
Okay.
It's exactly the way it is supposed to be. Just to give you an idea, it's actually super complex. So I was talking about that we were trying to build this all possible multi-stage attack path simulation. Once we started working on that, we saw that it's a p-space complete problem. So those who are into algorithms, you will know that, after some time you will run out of memory, and it's just infeasible to solve such kind of problems. The moment the number of nodes go beyond hundreds, it becomes almost impossible to do stuff. Now I think we can do better, but then it goes beyond 1,000, it becomes almost impossible. So it's a very, very hard problem to solve. That's one. The second thing is, apart from that, there's another layer of complexity, which is there's just too many things. I'll give you an example. Like 10 years back, somebody asked, can you do something in security? My usual answer used to be, we just know one thing, which is penetration testing. We just know one thing. We don't know anything else. Today, I cannot tell that. The reason is, at that point of time, there was only network pen test. Now, we have network and applications, and in application security, we have SAST, we have DAST, we have IAST, we have RASP, we have real-time polymorphism, we have WAF. Now, imagine in 10 years, the thing which was 1 now has become like 10. And in security, there are some 30 to 50 domains, and each of these domains can be broken into 5 to 10 subdomains. And each of these subdomains are category in itself. Like SAST is a category in itself, and there are billion-dollar companies in SAST. So now look at this. There are 300 categories in security in which you can have a billion-dollar company. So it is super complex. You just can't do much about it. So, so one thing which is, I think, very important in security is maybe at some point of time to become philosophical. Okay, being technical doesn't help. So I look at security as very much like the happiness problem. Okay, so there's no single way to become happy, right? I mean, you need that car, you need that house, you need that friend or a nice wife or boyfriend, whatever it is. But then after some time, you'll see you need more, right? There's no one single thing that can make you happy. And the second thing is, so same in security, there's no 1 or 2 things that can make you secure. And the second thing is, whatever you do, you can't always be happy. Same thing is true for security. Whatever you do, you always can't be secure. So you will definitely be hacked. So one thing which is very important to do in security is, when you design security considering you will be hacked. The moment you look into architecture, considering that you will be hacked, now your strategy changes.
Correct.
Then you don't just try to detect and prevent, but now you think of response. Because now you know that I'm going to get hacked, so I need response. So how do I respond? There are lots of technologies and processes and stuff like that. And then the fourth layer comes in, which is prediction. So that is that how do you know who can try to hack you? What kind of capabilities they have? What are the kind of strategies they use? This is exactly what CIA does or any of these 3-letter agencies do, right? They try to kind of figure out who could try to have a terrorist attack and what kind of styles they use in their attack. So when you look at security, you have to look into security considering that you will be hacked. So along with detection and prevention, have response and have prediction as a part of the strategy. Now this is at a very broad level. You have to go deep down and get into those 300 categories of products.
Got it.
And build that program in place.
All right, so coming to you, Supriyo. So we heard the past. So we're entering to the future of connected everything, right? So why do you think security is so important right now?
So like Vikas says, right, there are multiple paths, right? And if you look at today that one of the key issues coming is that era of Internet of Things, right? So while it is Internet of Things, it is also maybe bringing up the era of Internet of Threats, right? Because so many volumes of devices. If you see the ecosystem today, right, everything is interconnected, right? And there's so many. And so if you take the interconnected devices today, as for IDC, it is 6.4 billion devices in today, and it will go up to around cross 20 billion in 2020, right? So it definitely gives multiple attack points, right? And the another key issue is that these devices are no longer, it's earlier in the computing era, right? It's in a data center, right? It's in a protected place, right? But the devices are actually, most of the devices today, entry point is unprotected, right? And so it gives lot of multiple threat surfaces as well as multiple attack points, right? It's a mesh, right? And you do not know where the mesh it will come from, right? And third thing is that if you look at that, it is no longer your stealing of the data or stealing of your bank, right? Hacking your bank account kind of stuff. It could be very fatal today, right? If you take autonomous cars, right, or driverless cars, right? somebody can break it. Somebody can make your windshield scattering like this, right? And it will be fatal today, right? You take medical devices, right? Medical devices are all connected, right?
Right.
Somebody can hack into your medical device or your pacemaker and can stop it momentarily, right? And so that is the third thing, right? Fourth is that the cost of the breach, right? As per IDC, it is it will cross around $2.1 trillion in 2020 right now, and it is exponentially increasing every year. And fifth is that the privacy and confidentiality data, right? Especially for the medical, right? Medical is, if you look at, a lot of innovations are coming in the medical today, right? And it is more of a diagnosis, more of the equipments coming in, right? At the same time, right? People can hack into your device and can take a lot of personal data of you, right? So that's why it is becoming very, very difficult, and Internet of Threats can come.
Great. So coming to you, Anand, do you see this as an opportunity to set the past mistakes right and build the right, be it the products or secure products or the security products itself?
I think it's definitely an opportunity, like Supriyo said, I mean, he talked about the number of connected devices, right? I mean, if you look back at the last 50 years of computing and the types of devices that people have been using, you think about conventional computers, desktops, laptops, and you think about smartphones and tablets and other things. We're roughly talking, maybe, somewhere around 2 billion laptops, things like that. You add in your smartphones and your tablets, and you're probably going to touch 7 or 8 billion devices. Mm-hmm. And when you talk about the Internet of Things by 2020, I mean, the numbers range, anywhere from the 20 billion to, I've read 35 billion. Correct. Right. So we are talking about an opportunity that is an order of magnitude larger than perhaps all of the devices that we've created and used, in the last 50 years, right? So being able to get security right, especially in an industry, if I could call IoT that, which is still in its infancy, I think is huge. I mean, if you look back at computing and the way people in the past Venkat was talking about some of the very early attacks, like in the 80s. And those were days when the approach to security was very, very reactive, right? The zeal to innovate usually far overtook the responsibility towards making secure products, right? And that has changed only recently, and I would say it's still changing. I mean, honestly, you look at a lot of development shops out there. Security is usually not top of mind. I mean, they're usually more focused on the features they're building and how quickly they can get to market, right? Security usually comes later; it's bolted on. So being able to change that with IoT, I think is a huge opportunity. I mean, it's not something any single one of us can do. Awesome. But here is something that is still in its infancy, and being able to and we know how we kind of know how this is going to play out because we know how the past has played out. So I think there's an opportunity to do things differently. Right. Absolutely. Right. Yeah.
So great. So we covered a lot around the evolution of the threat itself. So let's try to get into the building part of it, right? So I'm coming to you, Bikash. So the first thing is the software, which is most vulnerable in a technology stack, be it the hardware or infrastructure, right? So how do you actually build hyper secure software products?
Okay. So last time I was a little bit philosophical. Mm-hmm. This now time let me try to be prescriptive. Huh?
Right.
So I'll try to give you a kind of prescription, and before I give you the prescription, let me tell you it doesn't work. So, see, it's a very simple thing. Like, you all know the Turing problem, right? The Turing problem is the proof in itself that you cannot have the completely secure product. But you can have very secure product. You can make it super tough for the hacker to get demotivated enough to go and try to catch somebody else. So the key goal here is not to be the slowest zebra. Okay, then you will get eaten. Huh? So to be prescriptive, let me quickly ask, like, how many of you are architects, software architects? Okay, and how many of you code and write software? Great. Okay, so I needed to know this for my prescription. So few things which are very basic, which one has to do, and you guys, I'm sure you know, and you are doing it, is the dynamic security testing, which is dynamic application security testing, or pen testing, which people say. That is definitely a must. Then the static, which is the code analysis, SAST, I would say is the second thing which is very, very important. Huh? So most of the people in some way or the other do SAST and DAST. So how many of you do SAST, static code, using an automated tool? Okay, that's very
Quite
good.
a lot.
Okay, so that's like the first, I would say, first level. The next thing which most of the people don't do is architecture review and threat modeling. Okay, and that's super, super important. How many of you do formal threat modeling and security architecture review? Okay, that's great. How many of you use broader security architecture like SABSA? Okay, so you can actually integrate, have a broader security architecture and make your application security architecture as a part of it. That is the next level. So in terms of technology, if we look at SAS, DAST, and having architecture review is very important. The next few new things which are coming up, which I think you guys might be curious about, is something called the self-defending applications, which is RASP, R-A-S-P, Runtime Application Self-Protection. So please look into this. And the idea is something like this. So basically something like a small agent is sitting inside the application, and when the application is interacting with the user, data is flowing, it looks into what's happening inside, and if it sees something malicious is happening, it can raise an alert, and it can also terminate the connection. So it's like a self-defending application. The other thing is IAST, Interactive Application Security Testing. It's a combination of SAST and DAST. How many of you have used a IAST tool? Okay, IAST is new, RASP is new. These two are something interesting which you can look into. Then obviously, this is part of, say, building the application. Then just building the application is not good enough. You need to have a security program in place. So you need to have a software security group. And that means you need to have one guy who heads that group. And even though this looks like a very trivial thing, there's a very strategic reason to create a software security group. The reason is now to look at software security as not using some tools, but to build it as a program. So you have to build a software security program. And what are the things which are there in software security program? There are many activities, right? You have to have a lot of activities. Code review, testing, then having awareness. These are all various types of activities. So how many of you think, like, how many of activities do you think should be part of software security group? Just a guess. How many activities would be there? Just a guess. 5, 10, 20? 20. So approximately around 20. So it has been observed that there are 112 through a formal study, 112 activities that can be part of the software security group. So have a look at BSIMM, B-S-I-M-M. So BSIMM lists out all these 112 activities broken into 12 practices. So you can go back and see what is relevant for you, what is not. And not just that, it also tells you what percentage of organizations use that activity or have that activity. So you need to build it as a program. And I'll give you an example of one such activity which is non-intuitive, which you will not be able to guess very easily, which can be part of the program, which is, you all know about SOC, right? Where you have the SIEM, Incident and Event Management, and things like that. So in the SOC, when somebody sees that there is a kind of attack which is happening on the application, it can generate certain events. So you have those logs, and then there is correlation. So you see that this is an interesting pattern of attack which is happening on this application. So that information, the operations team should pass it on to the software development team. So now look at this. The program is not just part of your software security group. It is beyond, right? It goes to the security operations group. Then it can also have impact on legal and other factors also. Like you need to have very tightly written SLAs as a part of your third-party organizations with whom you are working. You need to look into what's inside the software of what you are getting. There are various kinds of tools which can help you to do that. So you need to build a program around this. So one is building the software, which I spoke about. You need to look into SAST, DAST, IAST, RASP, and stuff like that. But beyond that, go beyond that and build it as a program. Have a software security group and choose out of these 112 activities which are the ones which are relevant to you. So this was slightly prescriptive, right?
Okay.
But you have to customize your prescription.
All right. Thanks, Bikash. So, Venkat, so you have been part of McAfee and then now Intel Securities. So, what do you think some of those critical components of security products should be?
Okay, so first of all, thankfully a lot of people don't listen to Bikash, right? So that's where our business comes from, right? So, I mean, if everybody had listened to Bikash, I think I would have been out of my job. So, jokes aside, I think you have to look at what kind of threats we have today, and like Bikash was saying, once you're in an interconnected world, you have a digital system. It's a given that you're at risk, right? And the fact of the matter is there is no 100% protection that can be provided by anyone anywhere in the world at any point of time, right? That's reality. The thing is, given this, how do you make sure that you get the maximum protection that you can get? Right, the best protection that you can get, and how do you ensure that you're at risk the least? It's never zero, but it's all about how do you minimize, the risks to you and your digital assets. So the first thing is really about, when you create a security product, it's got to be, you have to think of it from a, threat intelligence standpoint. It's true in modern day terrorism, threat intelligence is a key component of, how we determine what the attacks are and, what are the indicators of attack, what are the indicators of compromise. And you need to have this coming in from multiple sources, right? It's aggregated data that needs to feed into a database that's in the cloud. You're able to make an analysis and get a sense of that. So the first thing is threat intelligence. The second thing is your security architecture that you're going to be creating has got to be open enough, not just for your own products, but for, it's about security connectedness. It's about, different machines talking to each other and exchanging information, threat intelligence, and all of that gets, essentially, it goes into the database, it is analyzed, and there's a lot of analytics, etc., that needs to happen. And then you've got to think about security in layers, right? So you have the endpoint, which is where you consume it, and then you have it at the servers, and then you have it at the network, and then you move on, you have the cloud, right? So right from client to cloud, you've got to think, you have to remember that, this is an ecosystem that is so interconnected. You're talking about potentially 1.2 billion people, especially on social networks that are connected. You're talking about anywhere up to 100 billion devices in the next few years that are talking to each other. So the amount of, the threat landscape is huge, right? The sophistication of the attacks is getting worse. So now you need to have a layered approach to this. So security at the endpoint, it's got to be a smart endpoint. It's got to be able to also do, some level of IOC and IOA, which means, it's got to be able to understand if, there are certain parameters that are changing that potentially are at risk and send this information to a threat intelligence platform which can do the work. Then it's also about having network security, right? And again, think about it. In a security scenario, when something gets compromised, the first thing that you've got to do is to isolate it. Mm-hmm. It's typical. You see this on TV every day. Each time there is a terrorist attack, right? So you have a bunch of people who go in and then they isolate the whole place, and then you have squads that go in. They do the detonation. So you need to have these systems that will allow you to move your data away into a different network where you're able to analyze things, you're able to detonate, you're able to then get a sense of what that malware is trying to do, and so on and so forth. And then, so which means you need advanced threat detection systems that can, not only isolate but also be able to run certain tests on them, so that you're able to get a sense of what, the potential malware is. So you have to have this at the endpoint, you have to have it at the servers, you have to have it at the network. So it's really a multi-layered approach. And overall, you combine all of these things together and these components. It's now, in the past, in the 80s, it was about, a straddling malware which was mostly black, which meant that, you identified a malware, you determined its signature, you put a DAT out, so it's blacklisted. And the other end of the spectrum, typically the way we look at how to deal with malware is you straddling between the black and the white. And what does that mean? So you have the blacklist, which is essentially your DATs that have the signatures of viruses and malware that have been discovered. So this is a reactive thing. And then you're looking at a whitelist where you're essentially saying, hey, I know this guy is good, right? So if this guy is on my system, I will let him in, right? And you started moving towards a whitelist approach primarily because your blacklist was growing, at such a pace that it was almost impossible to have that on your systems. And when you're talking about, your mobile devices and all of that, they come with, pretty small memory, right? So you're straddling between the white and the black. So you had the white component of it. And now, today, it's all about the gray. Right, it's the gray part. That's where the stealth is. That's where the malware is hiding. That's where you've got to have systems in place. So this is where the things like SIM come in, which is essentially about security information and event management. So you've got to be able to filter out relevant information. So this is about big data analytics. You have to do this in the cloud, and you have to make a determination based on patterns and so on and so forth. And then something will show up, and then you've got to start analyzing that. So you've got to have fairly sophisticated, complex tools and techniques that will allow you to address this holistically right from the client to the cloud. And again, you're looking at issues like BYOD, which means we are complicating things by bringing our own devices to the office. How do you segregate between your consumer and your corporate data? How do you ensure that that is protected? So there's this whole range of things where you need to have encryption. You've got to look at it's about data protection. How do data at rest, data in motion, data in use, and at each of these, you've got to have the right relevant solution and strategy in place from a security standpoint. So unless you do all of this holistically right through end to end, you're not going to be in a situation where you're reasonably well protected.
Right.
And that's really the state of play today.
Right. So Bikash mentioned about how to build the secure product, and you mentioned about spoke about the critical components. So critical components of the security products as such. So Anand, so do you still see any gaps, be it the technology or the security framework? And from a developing perspective, do you think that there has to be a complete mind shift?
I'm not sure if it's a mind shift. Mm-hmm. Clearly, when I answered the previous question, I talked about how, priorities, have always been a little off, right, in terms of when products have been developed in the past, and that's changing a little bit, as we come to the current. But basically, if you still look at a lot of development environments, engineering environments, and you look at the security alignment in terms of where security stands in the priority list of what it is they are trying to do, there's usually a misalignment. There's priorities are misaligned, processes are misaligned, and possibly tools are misaligned. With achieving highly secure products, right? And like I said, the approach is still reactive. Somebody I know once made a very interesting comment about just bugs in general. I mean, not necessarily security vulnerabilities, but just bugs in general. They said, hey, if you find a bug, when a developer finds a bug, right, then you found it in time. If your QA team is finding a bug, then you're finding it late, right? And when your customer finds the bug, then you're finding it too late. right? And that whole thing is even magnified, with security, because when a customer finds a security vulnerability, then you're in real trouble, right? So I kind of go back to Bikash's point about starting early, right? I think he mentioned BISM, and BISM, by the way, stands for Build-in Security Maturity Model, right? So how can enterprises adopt maturity models like that, BISM or anything similar, right, where you actually take security seriously from the get-go, right? So the question is not thinking security when you're testing the product, but thinking security when you're even architecting the product, right? When you're doing a design. Do the threat modeling at that point. Train your engineers to be defensive in their programming when they build in security right then, right? And your QA team should find very, very little security bugs, and hopefully your customer will find none, right? And we'll all put Venkat out of business. But I'm just saying. But I think that is the approach,
right.
Because if you try to look at security as how do I fix it, then it's going to seem impossible. I mean, like Bikash said, it may be an unachievable goal, but if everybody builds it in right from the beginning, it actually is a lot more surmountable. It may never be perfect,
right,
but it's a lot more surmountable. But I think the secret lies there. How can we get security top of mind at the engineering level, at the architecture level, so you start really, really early.
Right.
And we have a lot of wood to chop there. It's not there yet.
Right. So coming to you, Supriyo, I have the last question for you. So you mentioned about the ecosystem, the connected ecosystem. So what do you think some of the challenges from a security perspective for connected ecosystem, and how do you actually mitigate those?
Yeah, so we all talked about the software products, security products here, right? Or how to make the software more secure, right? But if you look at today's industry, right, a product guy is not only selling that product itself, right? He is selling the entire solutions, right? So, for example, if you take like a glucometer, right? So nobody is selling the glucometer itself. He is selling the glucometer. He is making sure there's a connectivity to his cloud, right? And from the cloud, there's a decision support system. And then he's sending this data to the physiologist, also selling this data to the insurance providers, right? So that they knows that what is the insurance pattern. Similarly, if you take the automotive companies, right? So automotive companies, he's earlier 10 years back, he's just selling the car. Now he's not only selling the car, along with the dashboard, he has got various infotainment applications. He's pulling data. He's also giving the services like the parking meter, right? Many of the guys are giving the parking meter solution in the dashboard itself, and he ties up with the third-party parking providers, right? So product is a entity, and is starting from device itself to the connectivity to the cloud, and then going back to the end device part of it. So that is the connected ecosystem problem today. You have to take care of the device, you have to take care of the connectivity, you have to take care of the cloud, you have to take care of the end device also, right?
Right.
Okay. And so I'll talk about some of the basic principles, because the basic, it starts from basics, which is it is not a reactive security. It is basically starting from the secure design concept itself, right? So a couple of things that, first of all, the device itself, as I said earlier, that the problem of the connected devices is the device is very unsecured, right? You can have that in an industrial control kind of an environment, right? The PLC could be lying into some shop floor itself, and that's the endpoint. And every of the devices has got a interface, right? It could be a communication interface, or it could be a JTAG interface, and you can connect from there and then hack it to the entire this one. You can enter, right?
Right.
So how to make the device itself is secure, right? So you basically use the technologies like the TPM kind of stuff. Use that, right? Trusted module, right? That is one part of it. Secondly, the authentications part of it is very important. That proper authentication has to be implemented part of it, right? So then the third challenge is today that, so that is from the authentication point of view. Now the device is sending the data, right? It either sending it to gateway or it is sending the cloud, right? So in that case, you have to basically make sure the encryption technology has to be there.
Right.
Now people are implementing the encryption technologies, but it is also important that, you know, you need to have a proper certification mechanism. You do the certification testing, that a pen test you talked about there, right? So for example, you cannot use in many places you use the self-certifications, but self-certification is not a right way to do that things, right? And then fourth part in the device is that, you know, most of the IoT devices are very low power devices, low computing, right? So you cannot implement a strong or compute intensive encryption technology mechanism over there. So there are schemes are coming which is a lightweight encryption methodologies, right? So this is, from the device side of it. Then when you take it to the gateway, so same principles also applicable to the gateway side of it. So which is most important is the authentication authorization standards to be implemented. Right. And the encryption has to be certified, right? And then we come to the cloud, right? You have to follow some of the basic standards, basic principles, like for example, the authorization part of it. Then most of the cloud providers are providing the security knobs, right? So you have to have the security knobs part of it, use that. Then also you must comply to the standards, right? You know, you have to make sure that whatever the cloud providers you're having, that IS and the PAS part of it is either, if it's a medical industry, you have to use the HIPAA compliance, because he basically ensures that security regulations of medical is taken care of, or PCI DSS compliant part of it. And the third part of it is that other endpoint is coming is the, mobile devices, right? For example, use the mobile devices to basically control the devices part of it, getting the data, right? So, and that's a threat point too, right? So there, which is important in terms of, authentication standard has to be implemented, as well as you have to have a role-based authorizations, right? These are the kind of technologies used.
Right.
Similarly for the web interface also. So
all right.
These are the basic principles we normally follow.
Great. So unfortunately, I've been told that there's no scope for Q&A. So let me just quickly summarize. So the first thing is we need to have a complete different perspective that I learned from Bikash. Basically more of a philosophical approach, that threat versus security. It can be some sort of a yin-yang approach where sometimes threat chases security, and then sometimes security tries to defeat the threat. From an implementation perspective, Venkat rightly said it is gray, right? It's no more the age of black and white, which means, as Anand pointed out, from a development perspective, at every stage, be it the architecture or design, development or testing, you have to have your checks and balances. And if you still fail, what I would say is, as Bikash said, at least disguise that is you're secure, right? Thank you, everyone. Thank you, panelists.